circular motion. Okay. Before this, we have studied some points in previous lectures. Okay. That is angular displacement. Okay. Now see here that angular displacement. What is meant by angular displacement? The angle described by the particle along the circumference of circle. Okay. So d theta is equal to delta x upon delta t. Sorry, delta s upon r. Angular displacement is equal to arc length upon radius. It is measured in radian. Okay. Next point, that is angular velocity. Angular velocity. Angular velocity is denoted by omega. Angular velocity is denoted by omega. So what is meant by angular velocity? The rate of change of angular displacement with respect to time is known as angular velocity. So it can be, the formula for angular velocity is d omega is equal to d theta upon dt. Rate of change of angular displacement with respect to time. Okay. So the unit of angular velocity, theta is measured in radian, time is measured in second. So the unit of angular velocity is radian per second, and the angular velocity is a vector quantity. Okay. Now next one, that is angular acceleration. Angular acceleration is denoted by alpha. So alpha is equal to rate of change of angular velocity with respect to time. That means d omega upon dt. Okay. So or we can also write omega t minus omega 0 upon t minus t0. Okay. We already know that this formula. Okay. So the unit of angular acceleration is radian per second square. Radian per second square. Okay. So these are the basic concepts, and we already find the relation between linear velocity and angular velocity. Okay. So the relation between linear velocity and angular velocity is v is equal to r omega, or omega is equal to v upon r. This is the relation between linear velocity and angular velocity. Okay, these are the basic concepts. Now we will learn what is meant by uniform circular motion. Okay, what is meant by uniform circular motion defined as can be defined as a particle is moving along the circumference of circle with constant speed. Okay, that particle is moving along the circumference of circle. Okay, we know that what is by circular motion? A particle is moving along the circumference of circle. Such motion is known as circular motion. Okay, now see, we are taking a string, weightless string. Okay, the one end of the string is fixed in my hand, and another end there is one chalk is attached. Suppose this is a particle. Okay, now see here, this particle is moving along the circumference of circle. Okay, such motion is known as circular motion. Okay, so the uniform circular motion means a particle is moving along the circumference of circle with constant speed. Speed is constant. Such motion is known as uniform circular motion. Okay, for example, the motion of the earth around the sun. That means earth is moving around the sun with constant speed. Okay, constant speed means the earth to complete one revolution along the sun, it requires 365 days. Okay, that means the speed is constant. Okay, now see here, this is the uniform circular motion. So next one, time period. Okay, what do you mean by it or time? Okay, now see here, if this particle is at position where A is the initial position, okay, let R be the radius of that circle. This particle is moving with a constant angular speed, that is omega, in an anti-clockwise direction. Okay, let us consider particle which is at position A, where A is the initial position, R is the radius of the circle. This particle is moving with a constant angular speed or velocity omega in an anti-clockwise direction. Okay, so what is meant by time period? If the time required, see here, the time required to complete one revolution, such time is known as period. Okay, so one revolution means if that particle is start from point A and it will move and again ends at point A, that means that particle is completed one revolution. Okay, so such time to complete one revolution is known as period. Okay, so what do you mean by time period? The taken by a particle performing uniform circular motion, performing uniform circular motion to complete one revolution, to complete one revolution, to complete one revolution is called as period. Means that motion is uniform circular motion and this particle is complete one revolution. So for the completing one revolution, the time is required. So that time is known as period. Okay. Now see here. So formula for period. Period is equal to circumference upon velocity. Circumference upon linear velocity. Okay. So circumference, formula for circumference is 2 pi r and the linear velocity is v. Period is indicated by t. So t is equal to 2 pi r upon v. Okay. So we already know that the relation between linear velocity and angular velocity. So v is equal to r omega. So substitute here. So we get t is equal to 2 pi r upon r omega. So r get cancelled. So t is equal to 2 pi upon omega. Or from this relation we can write omega is equal to v upon r. Okay, omega is equal to v upon r. Okay, so this is the formula for time period, or this also the formula for time period. So we know that the relation for the frequency, sorry, we can write here. Now see here, formula for period. Period is equal to circumference of circle divided by linear velocity. Divided by linear velocity. So we get circumference is equal to 2 pi r upon v. But we know that r. So substitute this value in this equation. So we get v upon r divided by 2 pi, which is equal to v upon 2 pi r. This is the formula for frequency. This is the formula for frequency. Okay. Okay. Next point, that is acceleration in uniform circular motion. Okay. Next point is acceleration in uniform circular motion. Okay. Now see here. Now see that observe this diagram. Let O be the center of the circle. Okay. Now let us consider a particle. Let us consider a particle which performs uniform circular motion. Which performs uniform circular motion along the circumference of circle. Along the circumference of circle of radius r. Of radius r. Okay. Now see here, let A be the initial position. A be the initial position of a particle at time t is equal to 0. Okay. And B be the final position of the particle at time t. At time t. So okay. Now see here, let AP bar and BQ bar be the linear velocities at point A and at point B. Okay. This OA and OB makes an angle delta theta at the origin of the circle. At the origin of the circle. So now we will write down the points. Okay. Let A be the initial position. A be the initial position of particle. Okay. B be the final position. B be the final position of the particle. Okay. In time t. Okay. Now let r, what is r means? R be the radius. R be the radius of circle. R be the radius of circle. Okay. V be the linear velocity. That means V be the magnitude. V be the magnitude of linear velocity. Okay. V be the magnitude of linear velocity. Now AP bar be the velocity of particle at position A. Okay. Now see here, AP bar be the velocity. AP bar be the velocity of particle at point A. Similarly, BQ bar be the velocity of particle. Velocity of particle at point B. At point B. Okay. Now RQ bar be the change That means B R bar is parallel to AP bar and B R bar is equal to AP bar. Okay, and join RQ. Join RQ. Okay, now see here. Let us consider a particle in uniform circular motion. Okay, let O be the origin, R be the radius of a circle, A be the initial position of particle, B be the final position of particle. Okay, V be the magnitude of linear velocity. Okay, R be the radius of the circle. Now AP bar be the velocity of particle at position A. Similarly, BQ bar be the velocity of particle at position B. Okay, so RQ bar, okay, RQ bar is the change in velocity. Now see here, we will consider, that is BR bar is parallel to AP bar, BR bar is parallel to AP bar, and BR bar is equal to AP bar, that means magnitude is same. Okay, and join RQ bar. Okay, so in triangle, now in triangle BRQ, in triangle BRQ, by using triangle law, so triangle law is P bar plus Q bar is equal to R bar. So now see here, BR bar plus RQ bar is equal to BQ bar. So BR bar plus RQ bar is equal to BQ bar. Okay, now see here, therefore RQ bar is equal to BQ bar minus BR bar. This term going to this side. Okay, now BR bar is equal to AP bar, so we can substitute here, that is therefore RQ bar is equal to BQ bar minus AP bar. So BQ bar means velocity of particle at point B, and AP bar means velocity of particle at point A. So this can be written as velocity at B minus velocity at A. Okay, so velocity at B minus velocity at A, that means change in velocity. So change in velocity means delta V. Okay, so therefore RQ bar is equal to change in velocity. Okay, understood? In triangle BRQ, in this triangle we use triangle of vector addition. Triangle of vector addition is P bar plus Q bar is equal to R bar. So we use BR bar plus RQ bar is equal to PQ bar. So this term is going to this side. So we get this. Now BR bar is equal to AP bar. So we are replacing BR bar by AP bar. So we get PQ bar minus AP bar. So PQ bar is the velocity at point B and AP bar be the velocity at point A. Okay. So we know that the formula for acceleration. What is the acceleration? The rate of change of velocity with respect to time. Okay. So we can write that is acceleration is equal to change in velocity upon time. Change in velocity upon time. So that is, it can be written as A bar is equal to limit delta t tends to 0 delta v upon delta t, delta v upon delta t. Okay. If this angle is delta theta, then this angle also delta theta because alternate angle. Okay. So angle QBR, therefore angle QBR is equal to delta theta. Okay, QBR is equal to delta theta. Okay, so we know that the formula for angular acceleration delta theta is equal to arc length upon radius. Okay, so angle delta theta is here, so arc length is QR upon radius that is BM, QR of RQ upon PM. Okay, so by using the formula of angular displacement, so RQ means delta V, BR means change in, BR is the velocity. Okay, so we can substitute, we get delta theta is equal to RQ means delta V upon V. So therefore delta V is equal to V delta theta. Okay, so substituting this value in this equation, so we get A bar is equal to limit delta t tends to 0 V delta theta upon delta t. V is constant, so we get V into limit delta t tends to 0 delta theta upon delta t, rate of change of angular displacement with respect to time. So we get acceleration is equal to V into omega. Okay, or we use this equation, V is equal to R omega, so we get A is equal to R omega square, or we substituting omega is equal to V upon R, so acceleration is equal to V square upon R. These are the formulas for angular acceleration in uniform circular motion. Understood? First, so see here, I can revise again. That particle, it is considered a particle which is revolving along the circumference of circle. Okay, the radius of the circle is R and this particle is moving in anti-clockwise direction. Okay, with a constant angular velocity omega. Okay, now see here, let A be the initial position of the particle, B be the final position of the particle, R be the radius of the circle, V be the magnitude of linear velocity. Okay, now AP bar be the velocity of particle at point A. BQ bar be the velocity of the particle at point B. RQ bar be the change in velocity. Okay, now we construct the diagram, that is BR bar is equal to AP bar and BR bar is equal to AP bar. Okay, so in triangle BRQ we are using triangle law of vector addition. So what is the triangle law of vector addition? P bar plus Q bar is equal to R bar. So we get BR bar plus RQ bar is equal to BQ bar. So BR bar is going to that side. So we get RQ bar is equal to BQ bar minus BR bar. Okay. So BR bar is equal to AP bar. So BR bar is replaced by AP. So BQ means velocity at B and AP means velocity at A. So that is velocity at B minus velocity at A is the change in velocity. So RQ bar is equal to delta V. Okay. Now we know that the formula for acceleration means the rate of change of velocity. So acceleration is equal to change in velocity upon time. So we get the formula A is equal to limit delta t tends to 0 delta V upon delta t. Now angle QBR is equal to delta theta. Okay, so delta theta is the angular displacement. So the formula for angular displacement is arc length upon radius. So we are substituting the values. So we get delta theta is equal to delta V upon V. So delta V is equal to V delta theta. Okay, so this equation can be substituted in the formula of acceleration. So we get acceleration is equal to limit delta t tends to 0 V delta theta upon delta t. Now V is the magnitude of linear velocity. This is constant. So this constant can be taken outside the limit. So we get V into limit delta t tends to 0 delta theta upon delta t. So we know that rate of change of angular displacement with respect to time, that is angular velocity. Okay, so we get acceleration is equal to linear velocity into angular velocity. So we are using the relation between linear and angular velocity, that is V is equal to R omega. So we get the formula V is equal to R omega square, or we are using the formula omega is equal to V upon R. So we get A is equal to V square upon R. This is the most important derivation. Okay, thank you.